So this module is about IP version 4 addressing, module 11. In this module, we'll look in the IP version 4 address structure, compare the characteristics of the unicast, broadcast, multicast, identify different types of IPv4, subnetting. We'll have subnetting, a very important topic in this course. So let's start. Again, in IPv4, we've discussed last time that it has two parts, network part and host part, that the total bits is 32. And there's that what we call a subnet mask, which identifies which part is the network and the host part. In the next part, I have a much detailed discussion about the IP version for address structure. Okay. So again, the subnet mask is the one that identifies which part in the IP version 4 is the network and the host part. And the rule is if it is 1 in binary, in bits, it's a network part. If it is 0, it's a host part. Sometime the subnet mask is presented in prefix length. Okay. Say for example, if the prefix length is /8, that's the subnet mask. This represents the number of network bits. So it means there are 8 ones. So in a 4-dotted decimal, it's equivalent to 255,000, so on and so forth. There's that what we call as unicast transmission. So for example, this computer will send a, uh, a data specific to the printer. So in unicast, if it is sent specific to the destination, the source IP is the IP add of the source. The destination IP is the IP address of the receiver or of the destination. If it is broadcast, there are like a couple of requests that are being sent to all. We uh, there are a couple of requests that are being sent to all. So if that is the case, the destination is a what we call as a broadcast address, okay, which are all in 255. Unicast is sent to a group. For example, this 172.16.4.1 will send a data specific to a group. So there's this what we call as a multicast IP. Example, it is set. Example, in this case, in these two computers, okay, the 43 and 44. We call this 224.10.10.5 as a multicast address. It defines that these two computers are in one group, and we call that as a multicast. We have two classifications of two types of IP. Okay, a public IP and a private IP. Say for example, your boss told you to assign an IP ad in a given room, and let's say there are 10 computers in that room. Can you assign 1111 or 2.2.2.2? No, it should be within the private address block. That's the standard. That if you were to assign an IP ad in a computer locally, it should be within the range of 10, okay, or 172.16 to 172.31, or 192.168.00 to 192.168.255.255. So we call this as a private address range, okay, under RFC 1918. Those that are not in this block are tagged as public, okay. Public IPs are the ones used by service providers in order for users to connect to the internet. So ideally, if let's say we connect to the internet, what the telco will give, what the telco, say PLDT, will give to our, say, phone, okay, if we connect to the internet, let's say using mobile data, ideally it's a public IP, okay. And then there's the concept of NAT. NAT is to be discussed in Cisco 2. For example, this computer here, this packet is, say, yahoo.com. It's a request going to the Yahoo server. That's what this envelope contain. So again, this happens first here in this computer, so this computer here, say computer A. What computer A did is it typed yahoo.com. Okay? So, when it press enter, you know what? The IP ad of uh, the source IP of that yahoo.com request is a private IP. Say the IP address of this computer, let's say it's 10.0.0.2. For example, that is its private IP. So when this computer here, computer A, type yahoo.com, so it will be encapsulated with this private IP. When it goes into the router, okay, when this router here receives that, what this router will do is to change this private IP into a public IP. Okay? So there is that public IP assigned to this network. So what the router will do is to change the private to a public IP. For that to happen, the NAT should be set up or configured in this router. Okay? So NAT should be properly configured in order for computers here in this network to connect to the internet. So NAT is a requirement in IPv4. It will be discussed in detail in Cisco Module 2. Okay? So again, what the NAT does is it translates the private IP into a public IP ad. We have this loopback. Loopback address is 127.0.0.1. This is the popular one. Okay. So, it is used to test TCP/IP stack, used to test TCP/IP. Very also popular to programmers. This is the IP ad used by example with the PHP SQL form to the database. It uses TCP/IP component and the IP address of the local host. The database is 127.0.0.1. Okay. To test if TCP/IP is properly installed, they usually ping this 127.0.0.1. Okay, there are embedded systems that they install TCP/IP module. For them to know if the TCP/IP module is properly installed, they ping this 127.0.0.1. There's also that what we call as a link local addresses. There's that IP ad we under 169.254. When we type ipconfig and we see this IP ad, that's a PIPA. That's a PIPA, automatic private IP addressing, and we do not want that. Okay, because if we see that and the setup of our computer is uh, to receive an IP ad automatic, and what the IP ad we see is 169.254, it means that the DHCP is not working, so you have to troubleshoot. Okay. In relation to the internet, again, internet backbone is in US, and the way, and again, very important component in the internet infrastructure is the IP ad. So the holder and the one that manages the allocation of the IP address is IANA. This is an organization in US. Okay, and what they do is they allocate blocks of IP to regional internet registries. Okay, there are around five. RIR. There's ARIN. In Asia, APNIC. So for example, let's say PLDT needs to have public IP, needs to have additional public IP. So they will get that from APNIC. Okay. Uh, we APNIC again is a regional internet registries. Very important in a given network, local area network, uh, the managing the broadcast domain. When we say broadcast domain, these are the area where broadcasts occur. Okay, and what we are just saying in the broadcast domain, for example, if you have 100 computers versus 1,000 computers, there's too much broadcast in a 1,000 computer of versus a 100 computer. Okay, and that is a big problem. The more computers you have in a given local area network, and take note that there are instances, there are requests, there are types of services wherein it is being sent to all. So very important to manage these broadcasts, these kinds of requests that are being sent to all. So if you have more computers, expected, if you're not going to manage the broadcast part, there's too much congestion. So a solution is segmentation. Okay? Better to segment your network. You will discuss more on segmentation, like this one, okay, grouping of your devices. That's what we mean by segmentation. This will be discussed in detail in Cisco 2. There's that what we call as VLAN. That is a very good, that is a nice feature of segmentation, and we usually set it up in a switch. Switch is in layer 2, so we also have to segment under layer 3, and the way we segment under layer 3 is subnetting, okay, which is discussed in the next part. part 3. Okay, so there. So example, if you have this VLANs here, administration, human resource, student, and accounting. So we have these different departments, and we've segmented our network based on these departments. So a way to manage the broadcast, and that helps to lessen congestion, is we allot a specific subnet for each of these departments. So how subnetting works, again, in the next video, uh, you better watch that. That is a very important process. Again, we call it a subnetting. Uh, IP address, very important, the IP network planning. Okay. It helps to develop a much scalable solution, especially in an enterprise network. Okay. Like the IP addressing scheme to use, the if you need to if you need to subnet your network, if you were to work with DHCP, what are those IP addresses that needs to run through DHCP, and what are those that are to be statically or manually assigned, and then your VLANs. Okay. uh, as you go along, you will be uh, you will learn DHCP and VLAN, that is discussed in Cisco 2. So, and the next is, again, very important to identify those addresses, those devices that needs IP address, the end user, servers, the peripherals, those servers that needs to be accessed through the internet, network devices like routers, layer 3 switch, gateways like routers and firewall. And this ends part 1. Next parts are very important, like the IP version for address structure, all about network address, host, and broadcast, and the classes. And the last one is all about subnetting. I hope you continue watching. This chapter is a very important uh, topic. Keep safe. Together we learn as one.